Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, August 25, 2023. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a very rainy summer evening in my hometown of Rockport, Massachusetts. These Earth and Space Reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining ecosystems, and who wonder about the greater cosmos and all that it contains. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on Cape-Ann's community access cable television channel hosted by 1623 Studios. I am grateful for the continuing interest and support shown by Rockport educators and students, Cape-Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, sundry Earth and space scientists, educators, and communicators, far-flung friends, family, and other curious folk. Thank you for your active participation, comments, and general encouragement. This evening, I have the pleasure of once again hosting Richard Luecke, a resident of Annisquam here on Cape Ann. Last September, he regaled us on It's a Big Universe. How has our understanding of it changed over time? This month, he will segue from the truly vast to a much cozier topic, namely asteroids, comets, meteors, and close encounters. Oh my. Richard is well known among his cohorts with the Gloucester Area Astronomy Club as a skilled astronomer and veteran raconteur. His sketches of the moon, planets, and other celestial objects continue to amaze and inspire the less artistic among us. Beyond Cape Ann, he offers his services as a teacher of basic astronomy for Salem State University's adult education program and as a summer astronomy guide at Acadia National Park in Maine. This evening, he will guide us on a bareback ride among the asteroids, comets, and meteors, including the few interlopers that sometimes get a bit too close for comfort. So before the night gets too long, let's get going. The Zoom platform is all yours, Richard.
All right. Well, welcome to you all. Should I hit the screen here? If this works.
There you go.
Okay. I don't want to be on that slide. Let's see. There we are. Going the wrong way. Yeah, the controls on this are different than if I just do it myself.
I think you want the arrow at the far left at the bottom.
Oh. Thank you, Bill.
Genius, genius, pure genius.
My father once told me, he says, unless you're extremely careful, you can learn something new every day. And he was right. I just learned something new here. So it talks about asteroids, comets, meteors, and close encounters. And just a little warning here. I developed this presentation for a more lay audience. So there are a lot of things in here that I'm sure that some of you know already, and maybe know in greater detail than I, but I think you'll still find some new information here, I hope. Because I found out a little new things over the past weeks just developing this. I gave this program twice up in the Skutik Institute a couple of weeks ago, and seemed to go well. So let's go. But let's start with a little audience warm-up here, if this will work. And
What about my little girl, right? But you never know what the future holds. It's a meteor shower. This new one you're tracking. How big? It's what we call a global killer. Nothing will survive, not even bacteria. The United States government just asked us to save the world. Anybody want to say no? Think we'll get a hazard pay out of this? Don't do it. They've made a few requests though, such as Oscar here's got some outstanding parking tickets. Max would like you to bring back 8-track tapes. Not sure if that's gonna work. Yeah, one more thing. None of them wanna pay taxes again. Ever.
Ever.
United States astronauts trained for years. You have 12 days. You stick that in me, I'm gonna stab you in the heart with it. On July 1st.
Tell me you've never let anybody down before. I never quit yet. How's that?
Earth's darkest day.
Considering I've never been this scared in my entire life.
Movie Man's finest hour.
Well, you get the idea. How many of those movies has Hollywood made now about asteroids hitting the Earth?
One of Armageddon is one of them, right?
Yeah. The latest was kind of a tongue-in-cheek. It was Don't Look Up. Did anybody see that one?
Yep.
That was funny, with Meryl Streep as the president. And they go and the astronomers say, this thing's going to hit the Earth. We only have so much time to try to deflect it. And her aide says, well, how's this going to affect the midterms? Let's think about that. So I don't know about you, but if you look on Google News on any given day, you will see one or another headline like this one on the screen, closer to the Earth right now, how sights asteroid past the Earth, blah, blah, blah. Shockingly close encounter. This is like practically every week. There's another one from NASA, one coming up. So there have been and continue to be many close approaches from space junk, asteroids, etc., within 300,000, that should be kilometers of the Earth, roughly the distance to the moon. 226 of them last year, and through July there were 50. So, this is a normal thing. I wouldn't be surprised if you went back in the records. We had similar close encounters, but once in a while, things go boom, and close encounters become actual encounters.
The eyes of the world today stunned by this image. This was debris from a meteor racing toward Earth, streaking across the sky there, crashing into the ground in those woods. And look at some of the other images emerging tonight. The cloudy trail the meteor produced, and on impact, this, carving a little pool into a frozen lake. It's the biggest meteor in more than a century to hit the planet. This one crashed in Russia. 1,000 people were injured from shards of flying glass and debris. Tonight here, we have learned there was no warning. More on that from NASA in just a moment here, but we begin with ABC's Kirat Radia in Moscow.
It came out of nowhere, a bright speck in the sky, soon streaking across the horizon, followed by an almost apocalyptic scene, a blinding flash of light, and then all hell broke loose. Dizzying explosions, shattering windows, knocking these office workers to the ground. These students were lucky, protected by curtains from the flying glass, and these men barely escaped the blast. In the streets, pandemonium. Terrified residents thought the world was ending. People started to panic. Somebody screamed, "The end of the earth," he says. The chaos of the meteor was captured on cell phones and on dashboard cameras of cars, so popular here in Russia. The blast was so powerful, it knocked down a wall at this factory. In all, over 1,200 people were injured.
Well, you get the idea. These things are around, they're close encounters, but occasionally hit the Earth. That happened to be a small one, about, if I recall, about the size of 2 semi-trailers. And it entered the atmosphere early morning, exploded into particles before it hit the ground, and the shock wave caused all that damage. So here's the agenda for this evening. We'll talk about the nature of asteroids and past impacts, meteors and comets, other possible colliders with the Earth, the probabilities that they've assigned to minor and major Earth strikes, and what Earth defenses were trying to rally to prevent really a catastrophic impact. And should we worry about this? So what is an asteroid? I think the name is kind of interesting. I'm sure that must be from the Greek for star, and oid is kind of like. It's kind of like a star, like a humanoid is human-like, but not really human. So we have asteroids. They're rocky bodies that orbit the sun like planets, but smaller. 20% are metallic, and they are among the lots and lots of junk that formed in the Earth, that from the early formation of the solar system. They were just too small to form into planets like the terrestrial planets. And the bigger ones probably ran into each other as they run into the moon and the Earth, and broke themselves into smaller parts. So there are lots of these out there. The largest of these, and the first to be discovered, was Ceres. Has anybody actually seen Ceres? Those of you who are amateur astronomers? I saw it once, and you could actually see through a 12-inch scope. You could actually see it was a spherical thing, not a pinpoint of light like a star. And I know it wasn't Ceres, maybe Vesta. I tracked it once, night by night, with a star chart just to see its movement. But other than that, not that interesting for astronomical observation. But Ceres is the biggest of these. It was discovered in 1901. That was the Italian astronomer. He was the guy that had the flying star named after him. Piazzolo, was that his name? 1901. And he thought he discovered a planet. Over subsequent decades, they found more and more of these things. And they decided, well, gee, there's so many, we can't just call them all planets. Maybe they were afraid they'd run out of Greek names of gods to assign to them. So they decided to call it an asteroid. And then much later, in 2006, the same group of people that demoted Pluto from planet status decided to call Ceres, and I think a couple of the other larger ones, dwarf planets, but just the big ones. Here are I think the big three. And you can see how small the third one is relative to, and the rest of them are smaller than that. But here's the relative sizes. Notice how pockmarked they are from impacts. We'll come back to that a bit later. Here's the size of Ceres relative to the Earth and the Moon. Pretty small. And occasionally, these things will hit the Earth. There was one that hit in Siberia in 1908 in a totally uninhabited area, no reported casualties. And I'm told that it knocked down trees for like 1,200 miles, 1,200 square miles. Here's one that hit in Winslow, Arizona, 50,000 years ago, estimated an asteroid to be 50 meters across. And you can see there at the over on the left-hand side, the visitor center and a road going up to the visitor center. Somebody once saw this picture and said, gee, aren't we lucky? It almost hit the visitor center. I hope to see this year. I'm planning as a bucket list deal to go out to Flagstaff. And this is 47 miles east of Flagstaff. So I hope to see this myself. One of the biggest, well, I'm going to skip this. This area, this is the Yucatan Peninsula, Mexico. Here's the main part of Mexico. Mexico City's over here. And 66 million years ago, a large asteroid, believed to be about 4 to 5 miles in diameter, struck this area, created catastrophic damage all across the Earth. It's estimated that in addition to the dinosaurs, about 75% of the existing animals on the planet went extinct from this one impact. I'm going to skip that. So it has a crater they found not about 10, 12 years ago by somebody who was drilling for natural gas and oil offshore. And this is an artist's idea of what it would have looked like after it filled back in. 180 kilometers across, 18 miles deep. And the impactor, like I said, about six miles in diameter, huge. Hitting the Earth at about 40 to 50,000 miles per hour. It sent up a debris column that rose high into the atmosphere with molten earth, other fiery things that spread all over the world, setting fires all over the world. And a huge tsunami that went probably halfway around the world, wiping out everything along the shoreline. They estimate that the waves from that tsunami were about a mile high. So you can imagine the impact that would have had. Fortunately, 66,000 years ago, our relatives weren't around, I don't think, at the time. Correct me if I'm wrong. But like I say, the dinosaurs were among those wiped out. So today, they say if you dig anywhere in the Earth, you'll eventually get to a thin line of charcoal, below which dinosaur fossils are found, and above which there are no dinosaurs ever found. It's because they're all wiped out. And that charcoal is the remains of all those fires that covered the Earth. It also sent up a plume of dust that darkened the sky, creating like a 3 or 4 year winter that wiped out a lot of the plant life. Depends on the sun. Also, any animal life that depended on those plants. So that was a big one, but there have been many others. This chart shows you where they have found evidence of previous impacts. And as I mentioned down at the bottom, I read this last week. I don't think it's confirmed yet. It was in a scientific paper. They found one in New South Wales, Australia, that had a crater of approximately 520 kilometers in diameter. The Chicxulub one in Mexico was 180, so it was a much larger event. And that might have been 200 million years ago. Of course, you see all those where those strikes were. 70% of the Earth's surface is covered with water. So there's got to be, if these things are randomly occurring, that there's that many more in what is now the ocean. Somebody at my last presentation of this said, "See, I noticed that all these impacts seem to be where there's in developed areas of the world, economically developed." He says, is that just a coincidence, or is that where there are people around who would be looking for these things? And I think he was probably right. But the Earth isn't the only victim of these impacts. If you look on the surface, any pictures of Mars, there are craters. The moon, of course, big craters, small craters, craters within craters. What is this? Venus. Other asteroids get beat up. So, let's go back to that one of the moon. So I imagine that the Earth, because it's a bigger target, has greater gravitational pull than the moon, probably got hit more than the moon itself during the early years of the solar system when there's just a lot more stuff flying around. But notice that these are all very well formed, have nice sharp edges to them. This is where maybe this impact split the surface, cracked the surface, and lava flew up and flew out of the core of the moon and filled in these mares, filling in old craters with lava, etc. But unlike the Earth, the moon has no atmosphere. I don't think it has any tectonic activities that would change the surface area. But on the Earth, although we probably were struck many more times, it's hard to see any evidence of asteroid impacts because we have an atmosphere, rain, erosion, wind that has smoothed out a lot of these things, and plate tectonics, which has raised levels and lowered levels. So the evidence of this is much clearer on things with no atmosphere like the moon. So this is I'm sure all of you have seen this one before. Here's the sun in the center, the orbits of the inner planets, the rocky planets here, and between the orbits of Mars and Jupiter out here, we have the so-called asteroid belt, all kind of in nice little stable orbits, millions upon millions of these things, large and small, mostly small, pretty stable. This is something I just heard about a few years ago, was that Jupiter has its own little followers and predecessor asteroids. One group called the Trojans, and the other is called the Greeks. Very cute naming thing. They are at those, what are they called? Bill, what is it? Starts with an L.
Lagrangian point?
Lagrangian points relative to the sun and the gravitational power of Jupiter that keeps them in fairly stable positions as all Jupiter and they go through their orbit of the sun. So in that belt, millions of pieces of rock, some metallic. If you added it all up, they would only amount in total to about 20% of the mass of the moon. So it's not a lot of stuff relative to the moon, the planets, but just lots of pieces. What we worry about are there are some that get displaced from their orbits for some reason, or have formed in some kind of an odd orbit that crosses our orbit at some one or more places in the course of our various orbiting of the sun. And those are the ones we have to worry about, especially big ones like this. That one, Bennu, I think it's called, it's big. This would be a major hit if it were to strike the Earth. So those asteroids, big problem. We'll get to more about how we're dealing with the threat. We also have meteors, more space junk left over from the formation of the solar system. Also probably the consequence of a lot of this stuff banging together into like little shards and little buckshot that comes off when these things collide in space. So they tend to be smaller. And these things are, we tend to think of them as something we see at night, but they're hitting the Earth's atmosphere day and night, to the point where they estimate there are like 50 tons of meteoritic material that fall onto the Earth every day, mostly just, the ash remnants of burned up meteors, some solid pieces. Did any of you get out to see the Perseids about a week ago, peaking at the 13th of? I was up in Acadia National Park at the time. We had a group outside 2 nights that were like perfect. I think the 11th and 12th, and we saw a lot of meteors, a lot of bright ones too.
Saw one.
Good. You know, I have a bad habit. I was up there once, and during the Perseids, I got a blanket, and I was down at Sand Beach, which is on Mount Desert Island, and laid down on the blanket so I'd be facing up to watch all this stuff. Next thing I know, it was 3:30 in the morning, and starting to get light. I fell asleep, so I missed the whole thing. Few terms worth noting. Not everybody knows this. A meteoroid is one of these pieces of junk floating in space. If it hits the Earth's atmosphere, it becomes a meteor. If it makes it to the ground and puts a hole through your car roof or worse, whatever, it's a meteorite. So just want to add that in. And these things have hit people's houses. Here's one from Canada, meteorite. That's a pretty big chunk of rock or metal, don't you think? That looks like about, what, 7-8 pounds, do you think?
Mhm.
Crashed into her bedroom. And there's supposedly a minute possibility of this ever happening. Here's a case from Alabama in 1954. This woman was in bed. She had her clock radio on her nightstand listening to probably the Grand Ole Opry, I assume, when a meteor came through the roof of her house, through the ceiling of her bedroom, hit the clock radio, ricocheted, hit her in the hip, causing this huge bruise. That's not a burn or anything that I know. I think it's just a contusion. I wouldn't be showing that off, to tell you the truth. Here's another, this one this year. In Titusville, New Jersey, meteorite, nearly 1 kilogram. How much is a kilogram in real numbers? Like pounds?
2.2 pounds.
0.2?
2.2.
0.2. So pretty big, heavy piece of rock or metal, huh? Okay. Now this one I just saw in the paper a couple of weeks ago. There was a farmer in Michigan whose father had found this chunk of something metallic looking on his farm after a meteor shower. And the farmer said, so his dad brought it home and they'd used it as a doorstop for a barn door for decades. And just lately he took it to Michigan State, something, to the science department, and said, what is this thing? And they said, well, this is an actual meteor. And somebody paid him $75,000 for that. So, you know, if we get lucky, your house may be hit by a big meteor. You'll get more than the house is worth. Whoop. Let's see. I can move this. All right. So major meteor showers occur when the Earth passes through the debris trail of a long gone comet. I think the Perseids are from a debris trail of the Swift-Tuttle comet. And I don't even remember that one or how often it comes. But this little scheme, here's the sun, Earth's going along in its orbit. Sometime in the past, this comet came from deep space. As it came around the Earth, its icy outer surfaces vaporized, and all the stone and grit and stuff that was embedded in that ice and snow fell off and formed a little debris trail that's been hanging out there ever since. So when the Earth comes along in its orbit and it hits this debris trail, you get this meteor shower. I always say it's kind of like if you were, I explained it to people about how this works. If you were driving down the expressway some night in summer at 70 miles an hour, and there was a big cloud of moths or something hovering above the highway, and you hit them at 70 miles an hour, they would splat, 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 splat against your windshield. And that's exactly what's happening when we're going on the highway at what, almost 50,000 miles an hour. The Earth travels in its orbit, and we hit this debut splat, splat, splat in our outer atmosphere. And that's why we have meteor showers at those particular times. Anybody have anything to add to that or any questions? Comments? Okay.
I have one comment for you.
Yeah, let's hear it.
You've given me a new term which I intend to wield with no restraint whatsoever.
Well, no,
Scopoid.
it's what?
Scopoid.
Scopoid. Kind of like a scope, but not really.
Yeah, like Stellina.
Oh, shame on you. He's having fun with that.
Well, I'm having fun with it too.
There's probably one in your future. You just don't know it yet. That's
I
another
don't have a
subject.
boat. I don't need
That's
an anchor.
another subject. We'll let that one pass. So other stuff, all this rocky stuff out there. I've told this, I think, to Bill, the story about the creation. All that rocky stuff that's floating around, asteroids, meteors and stuff. It's part of leftover from the creation of the solar system. And it reminds me, there is a lost chapter of Genesis. Not many people know about it. Genesis is about God created the universe, the earth, everything. And the seventh day, he rested. Well, in this lost chapter of the Bible, it says that on the seventh day, the archangel Gabriel came to him and said, "Boss, great job, but we got a problem." He says, "What is it?" "We've got a huge pot. We got all the rocks and junk, boulders. What are we going to do with all this stuff?" He said, "There's a place they're going to one day called Cape Ann, Massachusetts. We'll dump all the stuff down there." And in a way, the same thing applies with all these meteors and asteroids, junk left over that the creation didn't do the whole job. So that's my story, and I'm sticking to it. So comets. So you guys know all about comets. They come from way out in the Oort cloud or beyond. They're mostly ice and snow and grit and dirt and junk. And they appear we get to see them as in their major elliptical orbits make their turn around the sun. Sun illuminates them. And as that happens, the solar wind and the heat blow off some of that outer material, which forms a tail. And when I was a kid, I'd see pictures of a comet like that, and I said, "Oh, it's like a rocket. It's this propulsion thing pushing it along." But as I learned more about it, it was less dramatic. It's just this the stuff being blown off the surface. So the tail is always pointing toward the sun, wherever it is, and it gets away from the sun. That outer material is no longer sublimated, and the tail disappears. Interesting story. 1910, Halley's Comet. The Earth passed through, or was forecasted to pass through, the tail of Halley's Comet was estimated to be 25 million miles long. And Yerkes Observatory used its spectroscope to analyze the light from the tail and found that it contained cyanogen, a poisonous gas. in that tail. And since the Earth was going to pass through the tail, huge panic all over the world. A French astronomer stated that the cyanogen would impregnate the Earth's atmosphere, snuffing out life. So people were in a big panic. Some guys started selling comet pills that you could take to protect yourself. People were making various kinds of masks and going, I suppose, into bunkers through this. Well, nothing happened. There were prayer vigils, but nothing, turned out nothing happened. And that was Halley's Comet in 1910. A lot of people don't know this, but Edmund Halley, then he was kind of a contemporary of Isaac Newton back in the 1650s or so, and he'd never seen Halley's Comet, but he had records and chart positions that he used from decades in the past that he forecasted the next round they would come around, although he didn't live to see it. And so to this day, we call it Halley's Comet. What's lost in the story was he told his associates at the time at the Royal Society of all these scientists that, something like this could someday strike and destroy the Earth. Apparently, this was a thought that had never occurred to anybody. Asteroids, comets, and his contemporary colleagues recommend don't say anything about this. The church people will get on our tails if we mention anything like this, because the idea that God's creation, humans, and who's made in God's image would be wiped off out of existence, they would not like to hear that. So he kept that to himself, wrote it in a journal somewhere. I said, Ed, just cool it. Here's something I just heard about last week, that there is an asteroid, Phaeton, produces a comet-like trail of sodium gas. Same process of sublimation, heating of the asteroid, that somehow there must be some kind of sodium in there, maybe vents to the outside, that they have seen a tail on this asteroid. And as you can see at the bottom, this is from NASA, so it must be true. And you're seeing it on the internet, doubly true. I'm sure many of you remember this picture, the great comet ferrets. Gene and Carolyn Shoemaker and David Levy found this comet, one of many, that as it approached the planet Jupiter, was broken apart by the intense gravitational pressure of Jupiter. And people had the privilege, and I think this is the only time this has happened that I know of, where they could actually see fragments of a comet striking another planet, in this case, the cloud level on Jupiter, leaving these ugly scars that I think were around for 7 or 8 days. So we have all this stuff flying around. Meteors, not so much a problem. To me, meteors, asteroids, meteors are just small versions of asteroids. I don't know that there's technically any difference except their size, but we got comets going around. So what are the risks that we're going to get hit by one of these things in a very catastrophic way? Well, this is how they kind of sum up the odds, and it all has to do with size, and there's an inverse relationship between the size and the damage that would be done. With the small ones, not so bad. The big ones, big time trouble. So what they call city killers would be an asteroid, say 1/2 mile in diameter, And NASA estimates that one might strike the Earth every 10,000 years, but most of the Earth's surface is water, and a lot of the rest of it is unpopulated areas. So this might, wipe out a, 20 square, 30 square mile area, but if nobody's living there, no big deal. Or in the ocean, although I think it would be quite a tsunami if it hit anywhere near the shoreline of one of the continents. You have another category they call region or country killers. These are asteroids that be 1 to 2 miles in diameter. And again, the bigger they are, the less likely it is we'll get one. So they estimate a region killer might hit every 100,000 years. An Earth killer, like Chicxulub off the coast of Yucatan, where you'd have an object 5 miles or larger in diameter, one every 100 million years. So Chicxulub was 66 million years ago. We're not quite close to 1 million, but in statistics, it could be just as well could happen tomorrow as at the end of 100 million years. So those are the odds. I came up with this, I guess in business school, we used to make these 2 axis matrices is a thinking tool. And so I made up one for these dangerous bodies, where on the vertical axis, we have the probability of being hit from low to high at the top, and the consequences on the bottom axis going from minor to the right side were catastrophic. So again, this is no precision of science, it's a thinking tool. And just for fun, I put in other major things that would involve the Earth, like climate change, another pandemic, nuclear war, and I arbitrarily assign them probabilities and consequences. Although on second thought, I probably should have had a range for each of these going horizontally. Like nuclear war might involve the whole Earth, but it might just involve a small area of the Earth that would be catastrophic. A pandemic or climate change for some people might just be a, really a difficult thing. But if you lived in an island in the Pacific that was 0.5 meter above sea level, it would be absolutely catastrophic. But take it as it is, just a thinking tool. Now let's put these in here. Small meteors, high probability. In fact, absolutely. I mean, they're hitting the Earth all the time with minor, if negligible, consequences. But then you got your city killers, your region killers. Because the probabilities going down with the effects. Does anybody have a thought about there, or maybe where these things should be repositioned?
What's the
Is this
timeline?
I'm sorry, go ahead.
Probabilities doesn't need a timeline, I don't think.
Okay,
It depends on whether this is a logarithmic plot or a linear plot.
This is linear.
ooh. I don't know. I accept that as a graph giving me
Looks
eyes.
exactly like the HR diagram.
We're right in the middle, right?
The giants are in white font, and the all the yellow fonts is your
Yeah.
Regular stars.
So the red ones, where would they
main
go?
sequence.
Would the red ones go? We're down here somewhere.
Yeah.
Let's move on. So So there is real danger here. No denying it. So what are we doing about it? So I don't know when it was. Congress charged NASA with the job of identifying and tracking 95% of all what would be called potentially hazardous objects, sometimes called, what do they call them?
Near Earth objects?
Near Earth, yeah, stuff like that. I can't remember the terminology.
NEO.
Yeah. And then since then they said, well, let's also categorize these in terms of what they're made of, or what they represent in terms of Earth problems to the Earth, and think about how we might mitigate these things. And at this point, and this was not just the U.S. only, although we I think started it all. Other organizations, the ESA and others are in on this. There's a international network, and there's a database that they feed all their information into. They developed a thing called the Torino scale, which rates the probability of a collision, and they assign numbers to what they found. And I think to this day, they believe they've found 90%, although they keep finding new ones. So they obviously haven't completed the list. All right. And here's how they're doing it.
Catalina Sky Survey and other survey programs are really sort of the start of the whole planetary protection ecosystem. It starts with discovery, goes on to follow-up and characterization, impact risk analysis, mitigation studies, but you can't follow up and you can't characterize and you can't calculate the impact risk of something you don't discover. In order to find a near-Earth asteroid, we take 4 images of a patch of sky separated by about 5 minutes.
And we take those 4 images and we blink them really fast, and it creates this little animation. So we can see that the stars in the background are static, as they should be. And if there's anything that's moving, it'll pop out.
And our software compares those images and identifies things that are not moving, which are stars, and removes those, identifies things that are transient from frame to frame, and tries to link those up.
We've probably seen about 1 million asteroids in the last 7 years that the PANSAS has been operating. It's like picking a needle out of a haystack. We're looking for distinctive motion, and when we see distinctive motion in asteroids, we report them to the Minor Planet Center. The Minor Planet Center is the sort of world clearinghouse for near-Earth asteroids.
The Center for NEO Studies takes the observations from the Minor Planet Center and computes the high precision orbits that we use to make predictions. CNEOS is also kind of an early warning system for newly discovered asteroids. We take the early data and we compute whether or not that asteroid could hit the Earth. If there's a chance, we'll send out an early warning and alert for follow-up observations so that we can get more data. And then we would know perhaps whether it can hit the Earth or not. Asteroid impacts are a fact of life. The Earth has been impacted by asteroids continually through its history.
We saw in 2013 in Russia, a fairly small, by the standards of what we're finding, asteroid did hit the Earth. I feel a little bit like a guardian of the planet. I'm doing my bit to try to protect people. It is a long-term process. It's going to take many, many years to find all of the dangerous asteroids. The goal is to find near-Earth asteroids before they find us.
Okay. All right. Your tax dollars at work. Right? There's also a NEOWISE, a space telescope which is using infrared to find these things. So they've found today 2,200 potentially hazardous objects. That's 460 feet or larger in diameter. They've identified them and they're their orbits. So it's kind of a messy thing, but they don't believe, based on their calculations, that any of these will hit the Earth within the next 1,000 years. But we'll come back to that later. But they did find one. How would we mitigate the problem? So they've had these, what would you call them? A tabletop gaming thing where they've had like 250 people from NASA, from the military, first responders, FEMA, all these groups, and said, okay, here's a scenario where we found this thing. It's going to hit Manhattan in 3 months. What can we do about this? In terms of evacuating people, preparing people, how far out do we have to go to get people sheltered? How will we deal with survivors? All these things. So they're actually working on this. The other thing is to deflect an object or on an impact course with the Earth. You all remember this from, what was it, a year ago this happened?
Yeah.
DART, I love these acronyms. It's the Double Asteroid Redirection Test, DART, where they found this asteroid, Didymos, and it has a little moonlet that's in orbit, caught in its gravity, Didymos B. And so they plan to ram a spacecraft into it and observe it in great detail, both from the Earth and from, I think there was another camera spacecraft out there observing it closer in to see, if the kinetic energy from that hitting this would be enough to deflect the orbit of this in a way that would change its trajectory. The idea is, if something's coming at you, if you can find it early enough and hit it with something, whatever, if you can just change its trajectory like even half a degree, and it's got three more years before it gets to the Earth, that little change in trajectory would make it miss the Earth by a long margin. So it did, in fact, slow this thing down and changed its orbit around this thing to the point where they said, yeah, this seems to work as a proof of concept, but they have to develop this further to make it effective. Problem: if they did see something which they didn't expect to find, and they say, oh, it's 3 to 4 years out, or 3 years out, or 2 years out, NASA is not equipped today to prepare, launch, and intercept an Earthbound astronaut. There's no arsenal or inventory of deflective spacecraft available to go after something if something showed up tomorrow. My guess is that this is something they will build in the future, so they're prepared. So they came up with this. This is just a month ago. Scientists predict next 1,000 years of asteroid impacts. Are we safe? Yes. No asteroids 1 kilometer or larger are predicted to strike the Earth in the next 1,000 years. And I put this bus down here. We don't always see them coming, especially from the direction of the sun. Do you remember these things? Like there was one that hit in Nigeria about 6 months ago, totally out of the blue. They had no clue. Came out of the sun. The telescopes couldn't see it. So, they shouldn't sleep perfectly well at night. and they should be preparing for these out of the blue episodes. So, should we worry about these things? And personally, I hearken to that great American natural scientist and philosopher, Professor, what's his last name? Alfred E. Newman. And he's not worried. So I guess we can all sleep well tonight. Any comments? And that's the end of my program.
Very lovely. Thank you very much.
I think there's going to be some progress with spotting those not close to the sun with the new survey scopes coming on board, like the Vera Rubin telescope. And so that's a bright spot.
Would a satellite scope do that? If they positioned it in a way that it would...
I don't know if there are any being planned. The Vera Rubin scope is a wide field imager on the ground.
Yeah, I remember living in New York and going to the Hayden Planetarium and seeing the huge iron meteor that they had on as an exhibit, that 11 tons or some ridiculous amount. And, you know, as a child, it's like, holy moly, this hit the planet somewhere and they brought it here to show us. It's incredible the damage nowadays with populations the way they are. If something like that landed anywhere near it.
Yeah, the problem is that Bruce Willis isn't available to go after it.
Soho catches comets plunging suicidally into the sun all the time. You can't look at 30 seconds of Soho video and not see a comet plunging to its death that they didn't know was around. So,
yeah, I thought there was a camera on the impactor that they actually used, and then they had another camera showing the plume, and of course they analyzed the change in the orbit. But I remember a live feed of riding the thing in, and you see bigger and bigger craters and more detail, and then it's, you know, cut to black on impact.
Yeah.
You don't remember that, any of you guys?
Yep.
oh yeah.
Yeah, it was
was
that
that?
probe.
Is that the one that they decided that when they got close to it, they decided it was basically a pile of gravel flying in formation? It wasn't like a solid body or something.
It was loose.
Yeah, a rubble pile.
Yeah.
But, you know, they deflected it enough to see a speed difference and an orbital change. So, hey, it's an effort. I hope they can figure it out.
Yeah.
I think maybe that's why Musk wants to go to Mars.
Well, there are two other methods that have been suggested, haven't been tested. One, I think, was the original one that people came up with. They say, let's just send up an atomic bomb, blow the thing to smithereens. But they said, well, so otherwise we have a bullet coming at us, and maybe it'll hit us, maybe it won't. Or if we blow it to bits, we've got a shotgun blast coming in our direction. It sure hits, maybe smaller bits. The other is the idea of sending a spacecraft with sufficient mass to fly next to it, that the gravitational interaction between the two spacecraft and the asteroid will change its trajectory.
A gravity tug. You just pull it along.
Yeah.
Nowadays, they could park a rocket engine on it and do some real driving. But hey, you know, you hope for the best when it comes up to moving something like that. Yeah, it's incredible we can see them nowadays.
Yeah, and tell me if I'm thinking wrong or not, but they've plotted these orbits or trajectories for all these potentially hazardous objects, but those could change, could they not? Could they
Easily.
interaction with another another body, or maybe a comet that comes out of, deep space and it's near one of those asteroids and it deflects, or just the heat of the sun could.
All of that.
Yeah,
Gravitational, what you're saying, yeah, sure, why not?
so I wouldn't put a lot of faith in that. Nothing within the next 1,000 years will hit the Earth.
I have to go to bed nervous now.
Yeah. But if the what me worry kid isn't worried, maybe I won't.
Yeah.
Yeah, I got his comic books right near me here, so I'm not worried either.
All right.
Good idea not to worry about things you can't do anything about.
Right. Exactly. There it is, your Mad magazine.
I'm not kidding, guys. My wife was a big kid at heart.
Now, Richard, I know you're fond of tracking comets. Are you excited about any comets to come?
Yeah, there are 3 that are promising. Hartley, which is currently in the Andromeda, not far from, kind of between M31 and M33 as of the other night. I was out the other night. Trees obscured my chance to check it. Checked it about 3 weeks ago, saw nothing. And a couple nights ago, I was out and I looked for Pons Brooks, which should be, like 11.7 magnitude. And it's right in the head of Draco, the dragon. And I was right on the spot. I saw it 3 weeks ago, in my averted imagination, I think. Wednesday night, I could not see it at all. But there's this one that the Japanese guy found. It's in the morning sky in Gemini. It sounds more promising, although its position is going to be kind of lost in the sun before long.
Right. And now you're hunting those with a telescope whose mirror is how big in diameter?
It's a 15-inch Dob.
Yeah.
I should have done it when I was up in Acadia, but I had my hands full and I didn't do it.
Right. So it's a challenge for people to discover these comets and to track them.
And in my case, a real time waster last week.
But there have been some fabulous comets over decades that we could behold, and you showed a nice picture of comet Neowise, which was the last good comet.
I was sitting with my son earlier in the evening, just previewing this program, and he wanted to see the slides. And he was a helicopter pilot in Iraq. And what was it, 2004? Was that Hale Bopp, or what was there? He said there was this comet that they could see from their aircraft with night vision goggles, which amplify it like 10,000 times. That he said it was stunning. I don't remember what that was, 2004.
Yeah, I don't remember what comet that could have been.
Yeah. Dick, Bill, I remember reading one of these 3 comets that we were just talking about was thought, this is just a few days ago, I don't know where I saw it, to be a candidate for an interstellar object. And I was wondering, they got to do this with spectra, right? There's no other way to do it unless it's orbit. Is it more orbit or is it more spectrum?
I think it's more orbit. If it has if it's going too fast by the time it gets into the inner solar system, that means that it's aphelion, its farthest part of its orbit is well beyond the solar system.
Cool.
And I think that was the case for the one that I cannot pronounce.
That's it.
Mama. I don't know.
Oumuamua.
Oh, say it again.
Oumuamua.
Oumuamua. All right, excellent.
Just pretend you're a Haitian cow.
Put marbles in your mouth.
Oumuamua. Excellent.
There you go.
Yeah, they still don't know what that was. The problem was it came close and now it's gone.
What's going on with Apophis? Are we waiting for a keyhole?
What a name for an object.
I know. It's terrible. It's
Apophis.
the worst.
It's
Death. It's from the Greek.
I think it's been downgraded, the likelihood of it colliding with Earth.
I thought there was a keyhole and then a comeback like 12 years later or something. This is a
Right.
2029 or 2026.
2029 is the
call.
one I remember.
And then if it does come back, like in the 30s, to be not a good day. And that's all speculation
Right.
from a long
And-
time ago.
And as you said, Artie, the things can happen between the first close approach and the next.
Of course.
Yeah, like I could die.
Well, I wouldn't have to worry about this, would I? Something to look forward to.
Yeah, right.
Yeah.
All right. Well, I think we've had enough fun here. I'm going to call it an evening and wish you guys all well. Thank you, Richard, for a fabulous scopoid. He just won't let it go. Thank you, Richard, for a great story about something that could be near and dear.
Okay.
Maybe I'll
So-
see you around town.
Wish you well, and let's hope that we get to see some nice comets from a safe distance.
Yeah.
Okay. Thank you,
All
guys.
right.
Nighty night.
Night all.